emitter terminal, collector terminal, middle part is connected wire, they call the base terminal. So in case of NPN transistor, it is reverse. It has a N-type material which has electrons, and P-type material middle, which is called as a base. This is called as base, and this is called as emitter, and other one is called as collector. Okay, so this is how if you see in electronic circuit, you will see only two type. One is called P-type or N-type transistors. Okay, so this is the physical structure, how it look like it. But I say cross-section view and approximate for understanding power. Actual physical circuit will be different, but for understanding, I've shown them. So you'll see that there are then symbolically the P-type transistors represent like this. Generally, drawing a transistor like this, you draw like this, then put one arrow in one of the outgoing this one. Then this is called collector, where arrow is called emitter. This is called a base. This is how you draw it. So you can see that that's what shown here. Generally, we put a circle also. Okay, if like this, if arrow is coming out, then it is called as a N-type material transistor. If it is arrow going, so you can see that this transistor emitter is marked with arrow ingoing. Correct? Arrow is showing towards inside. So this is called a P-type PNP transistor. Same way for NPN transistor, the arrow is shown because otherwise all things look same. Correct? The symbol, this is called symbol. Symbolic representation of transistor. Okay, this is called as NPN type transistor. Okay, this NPN PNP transistor can be represented like this. You can think that if I cut in the middle portion, if the transistor is divided into two parts in the middle section, you have N-type material, P-type. If I attach two wire, it is called a diode. Correct? Diode consists of one P-type material and one type. For understanding purpose, you would have studied, but anyhow, you can just show that. So this is P-type material, this is N-type material. This is called a diode. So you can see that this is connected. So now if I give voltage like this, the diode will conduct. Positive voltage connected to P-type material, negative voltage, N-type material, current will flow like this. So this is called ID, diode current. So the voltage called VD. If I apply external voltage VD, a current will flow inside the diode from P-type material to N-type material complete. This is what diode. So if I take same analogy, I can see that there are two diodes in both this one N-type, P-type. They were understanding purpose only. Okay. Now that is one thing. Next thing is, if I wanted to, we know that transistor can be used as an amplifier. I told biasing is nothing but giving voltage. Transistor can be used as an amplifier. Okay. If I want to make as an amplifier transistor, the transistor will be given with some voltages that called a biasing voltage. If I take, please see that arrow is going inside. So this is a PNP transistor. In PNP transistor, I have, for transistor, you need two power supplies. Okay. One is called collector emitter voltage. Other one is called emitter base voltage. We have to give two voltages. Okay. That voltage was shown here. So the base I am applying between the collector and the emitter, I am giving positive voltage. Correct. So emitter is given positive voltage, say plus. The collector is given with a negative voltage. This is given by one external voltage. Next slide, I will show that. Similarly, between base and emitter, correct, we are giving one voltage. Base is given positive voltage, and with respect to emitter, but with less voltage. Okay, we will see that how it is. If I take a NPN transistor, collectors will be, see in emitter we are given positive. In case of NPN transistor, collector will be given positive voltage, emitter will be given negative voltage using one power supply. Another power supply use, base will be given positive voltage with respect to emitter. So the two power supply. This is called a biasing. If I want to make the transistor work as amplifier, I need to give external voltage to the collector and emitter and base terminals. That is called as biasing. We will see in the next slide. So how we are going to bias? Right now, as I told you, both NPN and PNP transistor can be used as amplifier. And already I told you how the voltage biasing should be given. You need two power supplies. Correct? First, we will take the NPN transistor. NPN transistor, first power supply called VCC, which is going to give, we call it VCC generally. This is a DC voltage. You can see symbolic represent this one. It has a positive terminal, negative terminal. the negative terminal of the VCC should be given connected to emitter, because you see that negative is connected to ground, emitter also connected ground, but that means both are connected together, same, correct? One power supply that is going to give voltage between the collector and emitter. That power supply called VCC. This voltage is given through one more. The voltage from the positive terminal battery is not directly connected to collector terminal. C means collector, not directly. It is connected to one resistor called RC. Correct? RC is called as collector resistance. Collector resistance. This is symbolic. Sometimes they call it a load resistance. They call RL also load resistor. Okay. So that resistor is connected. One resistor has two terminal. One end is connected to VCC plus, other end is connected to collector of the NPN transistor. Emitter is connected to ground. So this is called as collector emitter bias voltage, VCC. Similarly, I have one more power supply. You can see that again it is represented by a battery, plus and minus. The minus is connected to ground. That means emitter, and this is all these things are connected. This power supply negative and this power supply negative, and emitter are connected commonly, okay, to ground. This is nothing but ground or 0 volts. Okay. Then positive terminal second power supply. The second power supply called VBB. Correct. Here I call VCC. This I supply called VBB. VBB plus is connected to one resistor called as RB. RB is nothing but base resistor. It is called as base resistor. Okay. Base resistor, other end is connected to base terminal, B terminal. So now, then only the transistor will work as an amplifier. This is called as biasing the voltage. Okay. Similarly, if I take instead of NPN transistor, if I take a PNP transistor also two power supply. You can say again it has VCC, it has VBB. Okay. But only thing difference is you can see that the minus terminal of the VCC is connected to collector. Correct. This is the collector of the PNP transistor. This is PNP transistor. Why? The arrow is going inside. Okay. The arrow is going inside. Here, the arrow is coming outside. That's why this is NPN transistor. In PNP transistor, collector is given with a negative voltage. Emitter is connected to plus. Plus terminal is connected to ground. Please note that it's not that you cannot connect plus terminal to ground, but it should not be connected to negative terminal. That's what you have to be, because sometimes students get confused. Okay. Then again, you have one more power supply, VBB. Already we can see that VBB is shown here. So VBB, the plus terminal is connected to ground. You can see that VBB second power supply is plus terminal, emitter of the PNP transistor. This is a PNP transistor, emitter, and this all are connected. This is called a ground. Plus voltage also can be considered. With respect to this voltage, this is negative. That's what is mean. So for example, this is 10 volts. This is 5 volts. Okay. The plus 5 volt, the negative, positive terminal connected to emitter. This is connected. This is become connected. The minus terminal of the VBB is given to base through RB resistor. RB other one is connected. Similarly, the VCC negative terminal is connected to RC, and they connected. So this is called as biasing the PNP transistor. Okay. So again, some more thing also I have written here. You can note down. Because this is emitter terminal, this is collector terminal. I am applying voltage VCC in NPN transistor. Note down, the plus VCC plus voltage should be connected to collector of the NPN transistor. Negative voltage should be connected to emitter. Okay. Then the plus of the VBB is connected to base terminal of the NPN transistor. Negative terminal is connected to ground, which is connected to emitter. This is a common. So since this is called as input, correct, voltage, this is called the output side. VC is called output side, and you can see that the emitter terminal is connected to negative terminal of this voltage, and also this one. This transistor, the circuit is called a common emitter transistor. Note down. They called as common emitter transistor amplifier. Transistor amplifier. Okay. Input is given with respect to base and emitter. Correct. Between these two, I am applying this voltage. Output is taken from collector terminal. That is called a V0. Note down. The output is taken from the collector terminal. So collect this voltage also measured with respect to emitter. This voltage also with respect to emitter. This voltage also with respect to emitter. Correct. So that's why it is called a common emitter transistor amplifier. We have what we call as common base amplifier. Similarly, common collector also is there. Common collector amplifier. Our interest is not, see, our interest is to know how the transistor works as amplifier. We are not going to discuss all these things. If you want to know, you can see some books and learn it. But basics, most of the amplifiers are common emitter amplifier. You need to know. Now that both this amplifier, NPN transistor and PNP transistor amplifier can amplify the signal. Okay. What is signal I am giving? Signal given to trans is nothing but base current, IB. Note down. That's why I made it bigger letter. IB is the base current. This is called as base current. Base current is supplied to base terminal. Correct? Base input. Correct? So who is supplying that? This power supply. Correct? Now you can note down, according to Ohm's law, current IB, which is going inside the base terminal. Correct? Who is supplying this power? So VBB supplying IB. IB equal to, write down the formula. Correct? IB equal to VBB divided by RB. Okay. So the current going inside the base terminal, which is, this is called an input to the transistor. This current will be amplified and appear as IC. IC is called as output. In transistor, IB is called as input, IC is called as output. Okay. The IC, you write down the formula, IC equal to beta times IB. Note down. The one of the important formula. So this formula only says my transistor works as an amplifier. Amplifier means amplify something. What it is amplifying? The base current. If I supply a base current, correct? So IB equal to, I say that 1 milliamps, 1 into 10 power minus 3 amps. What is my IC? IC equal to beta times IB. Correct? What is beta? Beta is called a current gain of the transistor. Note down. If I buy a transistor, you should ask what is the current gain. The current gain is decided by the manufacturer. Current gain beta can vary from 10 to even 1 lakh. The current gain of the transistor can vary from 10 to 1 lakh, but for a given transistor fixed. Correct? There are more than some 20,000, 15,000 transistors manufactured by different semiconductor manufacturers around the world. Correct? There are, for example, BC107 is one transistor. Okay, is beta. If you see the data sheet of the BC107 transistor, the beta may be 100. For example, TIP 122, another transistor. Okay, I'm just giving whatever I remember. Is gain equal to beta equal to 1000. I remember, still remember, beta equal to 1000. Like this, there are around 10,000, 20,000. Depending on whatever the current you want to amplify, you need to select appropriate transistor with having appropriate gain. We will see that later. Okay. So this is how the transistor works as amplifier. Okay. Now, in future, we are not going to discuss it because both are going to work as a transistor, and we will continue only with NPN transistor. Whatever you understand is applicable for PNP also. Only difference is the voltage, how you are supplying to collector. Correct? In PNP transistor, collector is supplied with negative voltage and emitter is supplied positive voltage. And the base is given with a negative voltage, collector is given to two power supply. But in case of this is positive, emitter is negative. So otherwise, all the rules are same. So that means we will talk about only this. So before going next, we know that I am giving a voltage at the base, which is I call VBB, and which is connected to a resistor called RB. RB is called as base resistor or base current limiting resistor. Both are same. Base resistor or base current limiting. Why it is called current limiting resistor? I already told you IB, which is nothing but base current, is proportional to VBB. What this voltage you are giving, correct? This voltage you can give, for example, if I take BC107, VBB can be given from 0 to 5 volts. Exactly, I don't know, for example, understanding. Okay, so that means I can vary this voltage from 0 volts, 1 volt, 2 volts, anything, even 2.2, anything, any value between 0 to 5. That is maximum. So the transistor, when I want to buy a transistor, you have to see data sheet. You have to see what is the voltage levels. VBB, what is maximum voltage? VCC, what is the maximum voltage? What is IC max? What is IB max and beta? Important parameters for a transistor, note down, is called as VCC max, VBB max, note down, IC max, then IB max. Lastly, beta. These are the important. If you see a transit data sheet, you will have other parameter also. There are many parameters. Those things are important, but these are main parameter for understanding. So these 5 parameters are very much important. So for any given transistor, this number will vary. VBB may be, for example, VCC may be 10 volts. But if, for example, take BC107 transistor, I don't remember exactly. You have to see this one for understanding what I'm telling. This may be VCC max may be 10 volts. That means this voltage. BC107 is a NPN transistor. I still remember. This is a BC107. It's a NPN transistor. Because I used it extensively when I was studying in college. That's why I remember. Tip 120 also NPN transistor. Okay, no problem. So the maximum voltage, this can be 1 volt, 2 volt, like this. Maximum you can apply 10 volts. You cannot apply 11, 15, 20. Something if you apply, the transistor will burn. Okay, that is what the VCC max is decided by the manufacturer. Correct? What is the maximum voltage you can give will be decided by the manufacturer. In the data sheet, it will be mentioned. It is mentioned here, for example, 12 volts, 10 volts. Similarly, base voltage, VB is called base voltage. Correct? That is, for example, it may be 5 volts. That means I can vary this voltage 0 volts, 1 volt, 2 volt, 3 volt, up to 5. Okay, input also, this is called VB is called input voltage. These two I can vary. Then IC max, what is the maximum collector current? Because why it is called collector current? From the VCC power supply, if I supply IB, correct? If I supply IB, there will be IC. What is the relationship? Note down. IC equal to beta times IB. This is important formula. This formula only says that my transistor work as an amplifier. What it is amplifying? It is amplifying the base current. How much it will amplify depending upon the beta. For example, BC107 beta equal to 100. Now, in the base, for example, this resistance RB equal to, I put equal to 1000 ohms. Okay, and I am applying 1 volt in VBB. I said any voltage 0 to 5 volt I can. VBB can be 5 volt. For example, I am giving 1 volt. What will happen? My IB equal to VBB divided by RB. RB already selected 1000 ohms. I will tell you how to select RB. Correct? RB equal to, already we saw, VB is 1 volt. 1 divided by 1000 equal to 0.001 amps, or 1 into 10 power minus 3 is nothing but 1 milliamps. Correct? So amps, or I can say 1 MA. I can say 1 milliamp. Base current is going. Now, what will be my IC now? IC equal to, already I told beta for this is, I said 100. Data sheet. That means 100 multiplied by 1 into 10 power minus 3. Correct? So it can be this one. 100 means it will become 10 power minus 3. Will be gone. Here 10 power 2 is gone. So your IC will be equal to 0.1 amps. Nothing but 100 milliamps. IC equal to 100. So now we can say that if I supply IB, which is input to the transistor base, then in collector, this is a collector current is called, this is called collector current. This is called base current. IB is called base current. Collector current is 100 times because the beta is 100. So I can say that my transistor work is amplified. Okay, that is one thing. Now another thing I already mentioned this. So now first relationship is IC equal to beta times IB. This is my relationship one, first equation. Second equation, the current is entering, correct, from VCC, this power supply, current is entering through which resistor? This load resistor or RC, collector resistance. enters in the collector terminal, comes out of this one and ends. This is called as collector emitter circuit. Note down. This is called as collector emitter circuit. Okay, so for that you are giving input voltage, because of that there will be a current flowing inside the circuit IC, and the IC is decided by IB and also this resistance. We are going to see that. Okay, that's one thing. So now the current from this is entering, and that current I call IC. Correct? IC is coming here. Please see that this is IC enters into transistor. Similarly, I am applying a VB. Because of this one, there's IB current is entering in the base. So this current is also entering inside this one. So please note that transistor cannot store current. Note down. So there's a base current entering through base terminal. From the collector terminal, collector current IC is entering. So since transistor cannot store current, what will happen? It will come out in the emitter terminal. It will come out as the emitter terminal. That's what shown here. This current is entering here. This current is current. The total current is coming. This is called IE. That is called IE is nothing but emitter current. IE equal to IB plus IC. This is the second relationship. First relation, IC equal to beta times IB. So this is how transistor is working as an amplifier. Another thing, I told you, if IB equal to 0, for example, this is BC 107, beta equal to 100. Okay, I am supplying VBB equal to, I say that VBB equal to 0 volts. What is my IB? 0 divided by this RB. RB I said 1000 ohms. Okay, so that is going to be 1000. So IB, so automatically IB equal to 0. If IB is 0, what is IC? Beta equal to 100 multiplied by 0. So IC also becomes 0. If base current is 0, then collector current is 0. This is input, output is 0. When IB is 0, when the base voltage, this voltage is 0, VBB equal to 0 volts, this one. Instead of that, if I give 1 volt, then IB will be there according to the formula. Now, one thing we have to note down is, in transistor, I said transistor made of silicon material, base material pure silicon, which is converted to semiconductor by adding aluminum or phosphorus, so that it become P-type material, N-type material. So it became a semiconductor. In silicon-based transistor, correct? Silicon-based transistor, majority of transistor, what you are finding will be silicon. They will also were using germanium. Germanium symbol is periodic table Si, Ge, silicon is Si. Germanium also can be pure germanium also insulator just like a silicon. Okay, by adding aluminum or phosphorus, you can make P-type material, N-type material. So, but it has a lot of problem. This was the first inventor semiconductor in 1960s. But after that, they found that silicon is better material than germanium to make transistor. So now nobody is using germanium. In silicon material, because all the transistor what you are seeing is made of silicon based material, then in which if I supply voltage VBB is correct, VBB is smaller than 0.7 volts, IB will be 0. Note down. This is another problem. What I said, IB equal to VBB divided by RB. Okay. I said RB equal to 1000 ohms. Okay. Now, my VBB, if less than, that means VB equals 0 volts or 0.1 volt or 0.2 volts, even 0.65 volts. Correct? If it is there, and RB equal to 1000 ohms, correct? There should be some IB, but IB will not flow. That is one of the important point to be noted. Correct? You should be noted when VBB, the input voltage base is lesser than 0.7, IB will be 0. Correct? That voltage, when VBB equal to 0.7 volts, then IB will start flowing. In that case, I say that my base emitter junction is conducting. I'll say base emitter junction is conducting. It is called a base emitter junction is conducting. Okay. So that means the current is flowing. Okay. How much current will flow? Now, small modification. Previously I said IB equal to VBB divided by RB. Now, because I said only when VBB is greater than 0.7 volts, IB will flow. Now, IB is new formula. We said VBB minus VBE, note down, divided by RB. This is new formula. Because the silicon transistor base to emitter will conduct only when the input VB is greater than 0.7. So that means you will see that if you apply 0 volts, no. 0.1 volt, no. I apply 0.7 volts. Correct? This is 0.7 volts. What will happen? 0.7 minus 0.7. Please note that when transistor start conducting, correct? We'll say transistor is conducting. Transistor is conducting when VBE is greater than or equal to 0.7 volt. That's what I mentioned. When this voltage is greater than 0.7, then only the transistor will conduct. So now, if I give, correct? If I give 1 volt here, there will be a voltage here. This voltage is called a VBE between base terminal and emitter terminal. This voltage. Please show that I have a power supply, one resistor, one base emitter terminal, which is nothing but a diode. Right? Actually, internally there's a diode there. So there are 3 components: battery connected to a resistor, connected to a diode. So that means I can draw this part as VBB, one resistor, one diode. This is base terminal. This is my emitter terminal. Correct? So now the diode will conduct when the voltage supplied to this is greater than 0.7 volts. Correct? If this is greater than, VBB is greater than 0.7, equal to 0.7, then only the IB will flow. Now, if I give 1 volt, VBB, correct? VBB equal to 1 volt. What is the IB? This is RB. This one, I can write new formula, IB equal to VBB minus VBE divided by RB. Okay. So now, if I give 1 volt, 1 minus 0.7 divided by RB equal to 1000 ohms, already told. This is equal to 1000 ohms. So divided by 1000. So it's going to be 0.3 volts divided by 1000 equal to 0.3 milliamps current. IB equal to. Now my transient gain equal to beta equal to 100. What is my IC? IC equal to 0.3 multiplied by 100. So 30 milliamps current will go. Not 100 milliamps. Correct? So this is how the transistor works. Okay. Any doubt in this? Because in exam you are going to expect problems from this.
Sir, in problems, how you can ask, sir? Just for it.
Yeah. We'll continue. Okay. So this is one. Then what about IC? IC equal to this current, collector current, IC equal to VCC minus IC into RC minus VCE. Okay. Divided by, okay. Okay. Let us start. I think next page we have the formulas. Yeah. Okay. The formulas are here. Okay. I remember. So we take transistor, correct? NPN transistor. We are supplied voltage. This is called as base bias voltage. This is called a collector bias voltage. Take the note down. This is what same thing. This is what I've done. I divided into this part separately and this part separately. This is called as base bias. This is called collector bias. I separated. That's why I brought it here. So this is called base bias circuit. This one. This is a combined circuit. Okay. Now, how to find out the base and current and collector current? So we can say that this circuit, I give VBB is the base voltage, and because of this IB current is going in the RB resistor, the voltage drop across this is, I say that VRB, that is this voltage is nothing but IB multiplied by RB. Okay, then this is my base terminal, this is my emitter terminal. Between these two, a voltage which is called a VBE, no doubt. That is what we have written here. Okay, VBB, correct? This is supply voltage minus voltage drop across this resistor is nothing but IB into RB, that is VRB, minus VBE, the voltage drop across this terminal is called 0. Correct? So now from this I can calculate IB equal to what? VBB minus VBE divided by RB. This formula you remember. Okay? Base current, previously what I said, IB equal to VBB divided by RB. I just modified because there's a base emitter voltage is there. This voltage is going to be fixed. Okay. VBE equal to 0.7 volts. When, note down, when VBB is greater than 0.7. Note down. Okay. For example, I say VBB equal to, you ask how the problem will come. I say VBB equal to 2 volts. Okay. Now automatically this one you have to remember. When if VBB is greater than 0.7 volts, automatically VB will be 0.7. So my VB equal to 0.7. Okay. Now what is the IB? Use this formula. My IB equal to 2 minus 0.7 divided by RB. RB already I told you, my RB equal to 1000. Okay. Then what will happen? Automatically divided by 1000 equal to IB. You got it? So in the exam, I'll say that I have a NPN transistor in which my VB equal to 3 volts. Okay. VBB equal to 3 volts. VC equal to 10 volts. Okay. RC equal to 100 ohms. This is called RC. This is 100 ohms. Okay. My VB, this is 1000 ohms. RB equal to 1000, RC equal to 100 ohms. And this equal to 10 volts. This equal to 3 volts. Now you compute this value. So IB you can compute. Okay. That's one thing.
Yes, sir.
Next thing is collector circuit, IC, correct? This circuit is a collector circuit. What is the voltage you are applying? VCC. VCC minus the voltage across this resistor is called IC into RC is called as VC. Okay, that is what is meant. This is called as VC. I am writing as it is. VCC minus IC into RC minus the voltage across collector and emitter. This is called VCE. This voltage is called VCE. This voltage called VBE. I told you base and emitter. It is called VCE. So now that you have the equation, I'll clear everything. You are very clear. VCC is the supplied voltage minus the voltage across this one minus voltage across transistor collector and emitter. This is called VCE is 0. Okay. From this I can say that IC equal to, correct? I can say that IC equal to, correct? VCC remain one side, VCC minus VCE divided by RC. Note down this formula. Okay. Now, how do you find out VCE? VCE equal to, suppose there are two things. If IC, now you don't know IC, correct? How do you find out IC? Already you have IB is known. Using this formula, you calculate IB. I am saying beta equal to 100. Beta is 100. No, this is very important because many times you have to know how the transfer works. That's why I'm explaining which is so much time. Okay. So now VCC minus this RC. IC, how will you find out? You know that IC equal to beta times IB. That's what I mentioned here. Once that is known, then you can find out what is VCE. VCE can be found out. Now IC is known and RC is known. I said RC equal to 100 ohms. right? So 100 multiplied by IC. IC is nothing but IB multiplied by beta. So automatically you can find out what is the VCE. And you can find out IC also. So this is why you compute the IC and IB for a given transistor.
Okay, sir.
Okay. Now,
Okay, sir.
yeah. Now another thing. The designing this is called designing the transistor amplifier. Okay. Next step is how will you find out what should be this RB, what should be this RC for a given transistor? How will you find out? That is very simple. Now, if I say that if a transistor is given, my VB, correct? VBB max will be given. Important parameter transistor, I said VBB, this voltage. What is maximum voltage? I said it can be given with 5 volts. For example, BC 107, VBB max is 5 volts. Similarly, this voltage VCC max, what is maximum can be given in the data sheet 10 volts. They say IC max equal to 100 milliamps, correct? IB max equal to, for example, 5 milliamps. Okay, they say beta equal to 20. Beta equal to 20. This is the data for the BC 107 they given. Now, this is my transistor amplifier. This is my BC 107. I want to design the amplifier. What is the designing? Designing is finding the RB value and RC value is called designing a transistor amplifier for BC 107. What will you do? You can find it very simple. RB equal to, note down, RB equal to, I already written here. Okay, RB equal to VBB minus VBE divided by IB max. Okay, what is the so here they already give us the VBB max. Okay, VCC max, VBB max minus VBE divided by IB max. VB max is given as 5 volts, correct? RB equal to VB max is 5 volts. They're given. That means you can vary from 0 to 5 volts. This is also 0 to 10 volts. So max is given. So that is VBB max is 5 minus VBE already know for silicon transistor is 0.7. Note down, it is 0.7. Okay, divided by IB max. IB max what they have given? 5 milliamps. IB max given 5 into 10 power minus 3. Okay, so that means 4.3 divided by 5 into 10 power minus 3 ohms can be written as RB equal to 1000 into 4.3 divided by 5. Correct? That is going to be 200 into 4.3. Correct? That is going to be automatically even if it take 4, 8, around 800, correct? Something 820 something will come ohms. So RB value can be computed. Okay, this is one thing. I know the time is up. When another 5 minutes you have to go to next class. I don't want every time hold up to 6 o'clock. So next thing is finding the RC value. Correct? While you find out RC value, note down this formula. RC equal to VCC max minus VCE divided by IC max. IC max already given. How much they given? 100 milliamps. So I say my RC equal to VCC max 10 volts. 10 volts minus, right? VCE, note down, VCE will be equal to 0.2 volts. VCE will be 0.2 volts when IB equal to IB max. Note down, when IB equal to IB max, VCE will be 0.2 volts. Okay, so I can supply with this one. Now I am already what voltage I am applying? 5 volts. That means automatically 5 milliamps current is going. So that means that is IB max. Correct? This is called IB max. IB max when automatically VCE will be in this formula, VCE will become 0.2. So I can say that 10 minus 0.2 divided by IC equal to my RC. What is my IC? Now IC equal to beta times IB. Already we found IB. IB which is how much? IB max is 5 milliamps. So 20 into 5, correct? Into 10 power minus 3 is my IC. Okay, automatically you will, so IC max already given. Already we know the IC max also already given as 100 milliamps. So I can say that 100 into 10 power minus 3. IC can be replaced by minus 3. So my IC equal to 10 minus 0.9, correct? 9.8 divided by 100 into 10 power minus 3. Okay, so that is going to be 9.8 multiplied by 1000 divided by 100. 100, this is gone. So 98 ohms. My RC, sorry, this is RC. RC equal to 98 ohms. Now I have designed my transistor amplifier. Okay. Any doubts? Because you can expect problem in the exam. I will give VBB max, VC max, IC max, IB max, beta max. Will be asked to design transistor, NPN transistor. Okay, you have to draw this circuit and find out what is RB, what will be the RC. Finding that is called designing amplifier. Then you have to draw the circuit. Tell this. This is 98 ohms. Other one was 820 ohms. Now you are designing amplifier. This is how the transistor is working as amplifier. Any doubts?
Sir, hello, sir.
Yes. Please tell me.
Sir, can you use some 2-3 example problems to us? Then we also can work it out parallelly, sir.
Yeah, we can work it out. Before closing, in the exam, what will you get is you will be asked to calculate power dissipated in the resistor. Correct? 4 power dissipated. I will stop here. Tomorrow we'll see that. After that, we'll go to APA. Okay? Tomorrow
Right, sir.
we'll continue this, and I will give tomorrow I'll solve problem also in class.
Right, sir. Right, sir.
2 problems I will solve. Then I'll go to APA. Correct? So
Right,
each
right,
class I'll teach, give some exam, any problem, like example problem, and complete the class itself, go to next. So that 12 classes, 12 different, this one will be over, you will understand. And I will try to complete today 1 class over, another 11 class, I will complete it. Then you can prepare for the exam. See you tomorrow. Give your
Thank you,
attendance.
sir.
Yeah, take care. Good luck. Yeah, thank you. Give your attendance before leaving.
Thank you, sir.
Thank you. Take care.
Thank you, sir.
Thank you.
Thank you.
You will get your marks for midsum by Friday. Thursday class. Thursday class, I will tell you what your marks individually. I am not going to tell in the class. It will be known to you by Thursday. Because Thursday we have 2 hours. Tomorrow 1 hour. Wednesday, Thursday 2 hours. That time I will. By the time you know your marks, I may email to you individually what marks you got in midsum exam out of 30. Okay. Thank you.